Hello students. Now we will see the next example in method of sections. We have already solved few examples using method of sections. Okay students, this is the next example that we have for method of sections. Now, it states that for the truss shown, we have to find forces in the members BC, CD, DE and EF by using method of sections. I'll just mark it that for you. BC is this member. Then we have CD, that is this member over here. DE, that happens to be this member, and EF, that is this member now. So in this case, now what is happening is we are having members in such a way that we won't be able to take one single cutting plane or the section plane. We'll have to take at least two separate section planes. So what I'll be doing is I'll cut the truss into two different parts now. One wherein I'll get the force in the member BC, or if it is possible, I'll take BC and CD. I'll try to do that first. See, if I cut like this with this member, that is AB, BC going like this, I can cut CD as well. So I have cut already three members now. And if I move on to this also to cut the truss completely, that means I'll be cutting four members. So in that case, I'm increasing the number of unknowns. I would like to avoid that. Then the next thing what I can do is I can cut the truss in such a way like BD, BC and AC is being cut. So the cutting plane goes like this. Okay. So I'll call this as the cutting plane 1, 1. Now, what I can do is I can first solve for this side of the truss. Now, in this, I can find only the force in the member BC. But before doing that, I need to find out the support reactions. To find out the support reactions, we have a hinge support over here and a roller support over here. Hinge support having two reactions and a roller support having one reaction. So the first step would be to find out the support reactions. In the horizontal direction, I'm not having a single force. You can see that I have only vertical force of 40 kilonewton at A, 30 kilonewton at B. So the reaction for this member, that is point G, sorry, it should be horizontal force at G. So I can say that the horizontal force acting at G is 0. The vertical force, I need to calculate that. Okay. And there will be one perpendicular reaction for this roller. I'll take it like this. So that would be HF. Now, what is happening over here? I have two horizontal forces, but not a single force which is acting in that direction. Two reaction forces, but not a single force. So I can say that Hg is negative of Hf. So I'll need to write this equation again. So Hg and the horizontal force at F with no active forces acting, so this would be equal to 0. So horizontal force at G will be the negative force acting at horizontal force acting at F. Now I need to find out the vertical reaction, that is Vg. Since I have two vertical forces acting over here, that would be same as the vertical reaction force. I got the reaction force at, vertical reaction force at G also. So that is coming out as 70 kilonewtons. Now, what I can do is, I can solve for this part of the truss or this part of the truss. Now, if I go for the right side part of the truss, that would be increasing the calculations because I have to go a long distance. So that means I have to add on the distances. And if I just take on this side, that is the side of the smaller side of the truss, in that case, the calculations would be less as compared to the right hand side. So I would prefer taking the left part of the truss. So I'll draw that part of the truss first. So I'm just considering the left portion of this truss now. Now, since we have to find out the force in the member BC, I need to take the moment accordingly. Now, what I'll be doing is, I cannot take moment about B because in that case, I'll be making the force in the member. If I take the moment about for the force BC, that would come out as 0. Similarly, if I take moment about C, again in that case, the moment for the force BC will come out as 0. So the better idea would be if I take the moment about point A. So in that case, what is going to happen is, this force, which I have assumed that it is acting outwards from joint B, that is this force. So I can take the moment as clockwise moment. I have a force acting over here of 30 kilonewtons. Even that force is going to create a clockwise moment. So I'll take moment about point B. So you can see that I've got the force for the member BC as, that is this force BC as negative force. So that means the nature of the force in the member BC will be compressive, and the value for that would be 30 kilonewtons. Then, now I have to move on to the next part. I have to take a section in such a way that I can find out the forces in the remaining three members. I have already calculated the force in the member BC. The next member happens to be CD. Now I have to cut it in such a way that I can cut only three members, and I'll try to cut the unknown forces, that is, for example, CD and DE. Now if I try to cut BD, CD, DE, like going like this, I'm cutting more members. So that is not feasible for me. What I would do is, I would cut it in such a way that I'm cutting BD, CD and CE. So in that case, I'm cutting three members and the unknown force, that is CD. Now this is my cutting plane number 2, 2. Again, what I'll do is, I'll prefer taking the left part of the truss. Now, if you look at this question, to find out the force in the member CD, I need to first find out the angle of this member with respect to the horizontal line. So what if I draw a horizontal line over here, a straight line perpendicular to FG? What I'm doing is, this is 2 meters FG, and from this point I have dropped a perpendicular on FG. So basically this happens to be then 1.5 meters. So this is 1.5 meters and this is 2 meters. So using this, I can find out the angle beta. So I have to find out this angle, so that would be this height and this length. So this is 2 meters and this is 1.5. I'll call this point, say, M. So that would be DM and CM. Similarly, I need to find out the angle of the force CE, because when I'll be taking moment about any point, this is the unknown force. I need to resolve this force. So to resolve this force, I need to find out the angle of the angle of the member CE. So for that, what I need to do is I need to find out this angle. I'll call this angle as alpha. Now to find out this angle, I know that this length is 0.5 meters. Not exactly 0.5 meters, it would be less than that because this length is 0.5 meters. So this is 0.5 meters and I know that this total length happens to be 4 meters. So I can find out this angle alpha. To do that, that would be the triangle C. I'll call this point as, say, P and this point as G. So in the triangle CPG, I need to find out this angle C. So I can find out the angles alpha and beta with this relation. The angle alpha is coming out as 7.12 degrees and angle beta is coming out as 36.86 degrees. Now, what I'll be doing is, I need to take the moment in such a way that I can find out the force in the member CD. To do that, I'll try to make the moment of this force, that is this unknown force and this unknown force, as zero. How to do that? What if I extend this like this, going back on this side and this line also going backwards? Suppose they meet at some point O. So what I need to do is, I need to find out this distance. If I can find out this distance, then I can do the calculations easily. Because, why? Understand this. If I take moment about O, this force, that is the force in the member BD, will become 0 because that is passing through the moment center. Similarly, the force in the member CE, even that is passing through the moment center, even that will become 0. The only force that remains is CD. If I need to resolve this force along X and Y, to resolve, I need the angle. I have already got the angle beta, that is 36.86. All I need to do is, I need to find out the distance OA so that I can take the moment easily. For that, I need to first calculate this distance D. How do I do that now? See, I know that this angle alpha is for this line with respect to the horizontal, correct? Now, if I take this line and I have extended over here, this line is also horizontal, so I can say that this angle is also alpha. So I have got the angle. I know that this length is 2 meters. Now, this is 2 meters, this is 2, this is 2, and even this is 2 meters. So that happens to be 6 meters. Now, how do I get this length? For that, what I can do is, Now understand what I have written over here. Tan alpha is nothing but basically tan theta is what the in trigonometric ratio, opposite side upon adjacent side. Now the opposite side with respect to this angle alpha happens to be FG, and adjacent side would be from O till F. I know that A to F is 6 meters. I need to add this distance, that is D. So that is the reason I have written it as D plus 6. Similarly, if I just do it for this triangle, that is OBC, still I have the angle as alpha over here. I know BC is 1.5 meters. So what I can do is, I can write it as opposite side, that is BC, upon the adjacent side. Adjacent side would be this distance, that is D, plus 2 meters. So if I substitute the values, I know alpha is 7.2. So, and BC happens to be 1.5. So I have got the length as D 10 meters. So I can say this length is 10 meters now. Once I have got this length, what I need to do? I just need to take moment about point O. If I take moment about point O, the force in the member BD is going to create a zero moment because that is passing through the moment center. Similarly, I have also said that CE is also passing through the moment center. So moment of this force will be again zero. Just resolve this force and take the moment. I have resolved this force at point C itself. So if I do that, the force, the horizontal component of this force BD is acting at a distance of 1.5 meters, and the vertical component of the force CD is acting at a distance with respect to O is 10 plus 2, 12 meters. Now the forces that are already acting on the truss are at A and at B. This is 40 kilonewton and this is 30 kilonewton. So I'll just take moment about O. So you can see that I've got the force in the member CD as 90.47. Since the value is positive, the nature of the force is tensile. The calculation is pretty simple. You can see that I've taken moment about O. The force 40 kilonewton is creating a clockwise moment, so that would be negative. 30 kilonewton force is again creating a clockwise moment, so that would be negative. The distance for the force 40 kilonewton is 10 meters and the distance for the force 30 kilonewton is 12 meters. So I have just written that itself over here. Then this thing FCD sine 36.86 into 12. What is this now? This force, that is the FCD force, I have resolved this force at this point itself. Now what is happening? This is the vertical component CD. Vertical component sine 36.86. Now this force is creating an anti-clockwise moment. So that would be positive. So that is the reason this is positive over here. And the vertical force is acting at a distance of 12 meters. So that is the moment I have written over there. The horizontal force is acting at the perpendicular distance for that is 1.5 meters. So that is what I have written over here. Simplifying that, I've got the value for CD to be as 90.47 kilonewtons. So I have already done the two members, that is CD and BC. Now next is DE. How do I cut the truss now? I need to find out the force in the member DE and EF. So if I do that, if I try to cut it in such a fashion, again I'm cutting extra members instead of 3 members. So I'll have to cut it in such a way that only 3 members are being cut. Now you can see that if I cut it along DF, DE and CE, so that would be going like this. I'll call this cutting plane as 3, 3. Again, I'll do the same thing. I'll prefer considering the right side of the truss. If I take right side of the truss, the left side of the truss, what is going to happen? I'll get a similar figure, what I had drawn earlier, somewhat like this. So I know almost all the angles, in fact, all the angles in that case, and the distances as well. So that would be easier for me to calculate. So now I'll just overwrite on this. Now what you can see is I have to take the force in the member DE, that is this member. So this will become my unknown force now, this one. Then DF is also being cut, so even that becomes my unknown force over here. Then even CE is being cut, so I have over here as unknown force. So what if I again take moment about O? Again I am simplifying my calculations in that case, because this force DF is passing through the moment center and CE is also passing through the moment center. So I can directly take the moment for this one single force, that is DE, and since it is vertical I don't have to resolve it. I have the distance for that, 10 meters plus 2 meter plus 2 meters, so that would be 14 meters. So I have got the force in the member DE as 54.28 kilonewtons compressive force. So I'm done with first, second and the third member. So that is BC, CD and DE. Now what I have left out with is EF. I need to cut it in the vertical fashion. In that case, again, I'll be doing the same thing. So you can see that in this truss, I have taken an example wherein we have to take n number of cuts. That is 4. So now again I'll do the same thing. I'll prefer taking the left part of the truss, because now you can see that with respect to joint F, the force member DF is going to pass through the moment center O, so that would be a zero force moment. Then this member, that is EG, is again passing through the moment center, so no moment for that as well. EF, I need to resolve that, and in that case the horizontal component is going to pass through the moment center, whereas the vertical moment won't pass through the moment center. So I need to take moment of that force. So again I'll take moment about O for force in the member EF. I've got again a negative value, that means the force in the member EF is compressive. The nature of the force, that is compressive. So in this way, I have found the forces in all the 4 members. I'll just write it down for you. First is FBC, that was through the first cutting plane that we had taken, and that you can see is coming out as this force, that is FBC, is negative 30 kilonewton. So that is compressive 30 kilonewton, compressive. Then with the second cutting plane, we had cut it in this fashion. So if I cut it like this was the member which I had to calculate, that was CD. So I have got the value for CD as 90.47 kilonewtons, that is tensile. So FCD is tensile. Then the next member was DE. For that, I had taken the third cutting plane and I got the value for DE as 54.28 kilonewtons, compressive. Then, to find out the force in the fourth member, that was EF, I had to take the fourth cutting plane and that I got the value as 79.24 compressive force. So you can see that in this example that I had taken, we had to cut 4 number of times this truss to find out the forces in the 4 members. So this was a typical example where you have to cut the truss n number of times. Thank you.